Landspace Zhuque-3 rocket achieves milestone. Successful static fire test marks key step in reusable rocket development. Date: June 20, 2025. Location: Dongfeng Commercial Space Innovation Test Zone near the Zhuque-3 Satellite Launch Center, China. Overview. On June 20, 2025, Chinese commercial rocket company Landspace successfully completed a crucial static fire test of its Zhuque-3 rocket. This test, which involved igniting 9 Tiangong methane-liquid oxygen engines, represents a significant milestone in the development of reusable rocket technology and marks a pivotal step towards Landspace goals in the competitive landscape of the global space industry. Test details. The static fire test commenced at 12 a.m. Eastern Time, 4 o'clock Universal Time Coordinated, 12 p.m. Beijing Time. During the 45-second test, the engines ignited in sequence, generating a total thrust of 7,542 kilonewtons kN. This test was designed to replicate flight conditions and included a comprehensive evaluation of major subsystems such as engine performance pressurization systems and avionics. The success of this test not only confirms the mechanical and operational integrity of the Zhuque-3's components but also lays the groundwork for upcoming flight tests. Landspace emphasized that this test was the largest and most automated parallel cluster hotfire test conducted in China to date. The rigorous testing process simulated the entire pre-launch sequence, including propellant loading, tank pressurization, sequential engine ignition, stable operation, and the planned shutdown sequence. It validated the compatibility of all major subsystems and verified the design of the ground support and launch control processes. Specifications of Zhuque-3. The Zhuque-3 rocket has a liftoff weight of approximately 570 metric tons and a height of around 66 meters. It is engineered to carry payloads of up to 21,000 kilograms to low Earth orbit (LEO) when used in expendable mode. If the first stage is recovered, this capacity is reduced to 18,300 kilograms. Notably, the design of the first stage allows for at least 20 reuses, which has the potential to reduce launch costs by 80 to 90% compared to traditional expendable rockets. The Zhuque-3's design notably mirrors that of SpaceX's Falcon 9, suggesting that Landspace is positioning itself to compete effectively in the burgeoning market for reusable launch vehicles. The first stage engine can be inspected and refueled without detaching it from the rocket, similar to the operational procedures of an airline. Context and future developments. Landspace achievements come after overcoming significant challenges, including the failure of its first rocket Zhuque-1 in 2018. The company shifted its focus to the Zhuque-2, which became the first methane-liquid oxygen rocket to successfully reach orbit in July 2023. The Zhuque-3 is part of a broader initiative aimed at providing low-cost cargo delivery to China's Tiangong space station. With its inaugural flight slated for the third quarter of 2025, which will carry a prototype of the reusable Haolong cargo spacecraft. The static fire test is seen as a vital step towards achieving more demanding milestones, such as reaching orbit and demonstrating safe recovery of the rocket's first stage. Observers noted that while this test marks a significant advancement in Landspace's development program, the company still faces challenging tasks ahead in its quest for operational success. Industry reactions. Analysts have stressed the importance of Landspace progress within the context of China's ambitions in reusable launch vehicle technology. Some sources have highlighted the potential implications for the global competitive landscape, especially given the rapid advancements made by other companies in the space sector. Conclusion. The successful static fire test of the Zhuque-3 rocket is a landmark achievement for Landspace and represents a critical advancement in China's efforts to enhance its capabilities in the global space industry. This milestone not only reaffirms the company's ambition but also sets the stage for future challenges as Landspace seeks to achieve its goal of reliable, cost-effective access to space. As the company prepares for its inaugural flight and subsequent recovery attempts, the world will be closely monitoring its progress in the evolving arena of reusable rocket technology. 1. Significant cost reduction. The development of the Zhuque-3 rocket by Landspace is notable for its potential to reduce launch costs by 80 to 90% compared to traditional single-use rockets. This is counterintuitive because the common perception in the aerospace industry is that reusable rockets, while promising, may not offer substantial cost benefits due to the complexities involved in recovery and refurbishment. Landspace design aims to challenge this notion. 2. High reusability claims. The Zhuque-3's first stage is designed for at least 20 reuses, which is ambitious for a rocket of its size and type. This level of reuse is not typically seen in the industry, especially in the context of methane-liquid oxygen engines. The expectation that the rocket could operate similarly to commercial airplanes with quick turnaround times for refueling and reuse is an optimistic departure from traditional rocket operation models. 3. Comparison to Falcon 9. The Zhuque-3 design shares similarities with SpaceX's Falcon 9, which is widely regarded as a benchmark in reusable rocket technology. This comparison is counterintuitive because it highlights the competitive nature of the space industry, where a new entrant like Landspace could potentially rival established players. The idea that a Chinese startup can develop a rocket that is directly comparable to an American industry leader is unexpected given the historical context of space technology development. 4. Successful static fire test versus future challenges. While the successful static fire test is a critical milestone, it also underscores the challenges that lie ahead, including reaching orbit and demonstrating safe recovery. The complexity and risk associated with these subsequent steps are often underestimated, suggesting that while the test was a success, it does not guarantee future accomplishments. 5. Technical fidelity to flight conditions. The test achieved a high degree of fidelity to actual flight conditions, which is often a difficult milestone for many rocket developers. The assertion that this ground test replicated the conditions of a real flight is significant, as many early tests struggle to closely simulate the various stresses and performance characteristics of actual launch scenarios. 6. Payload capacity discrepancies. There are discrepancies in the stated payload capacity for the Zhuque-3, with initial reports suggesting a capacity of 660 tons at liftoff, while later figures indicated a potential reduction. This inconsistency is counterintuitive as it raises questions about the reliability of early projections and the challenges of accurately estimating performance in rocket design. 7. Implications for global space competition. The advancement of Landspace and the Zhuque-3 rocket reflects a shifting landscape in the global space industry, where companies from different countries are competing for leadership in reusable technology. This is counterintuitive as it challenges the long-held belief that the US and its established companies would dominate the commercial space sector without significant competition from emerging markets. 8. Environmental considerations. The rapid increase in rocket launches, as indicated by the growth of companies like Landspace, could have unforeseen environmental impacts such as slowing the recovery of the ozone layer. This highlights the potential downside of the burgeoning commercial space industry, which is often viewed solely in terms of technological advancement and economic opportunity. 9. Focus on automation. The emphasis on automation in the Zhuque-3's test is striking. While automation is often seen as a means to improve efficiency and reduce costs, it also raises concerns about reliability and control in high-stakes environments like space launches. This duality, where increased automation can lead to both advancements and potential vulnerabilities, is a nuanced aspect of modern rocket development. 10. Government support versus market competition. The context of Landspace development, including government funding and support, contrasts with the challenges faced by private companies in other regions, such as the US. This discrepancy in government involvement can create an uneven playing field, which is counterintuitive to the traditional notion of a free market environment fostering competition and innovation. The successful static fire test of the Zhuque-3 rocket by Landspace on June 20, 2025 marks a pivotal moment not only for the company but also for the broader landscape of reusable rocket technology, particularly within the context of China's burgeoning commercial space industry. While many aspects of this development have been covered, there are critical details and implications that might be overlooked by the general audience. Key overlooked details and their significance. 1. Technical fidelity to flight conditions. The static fire test achieved a high degree of fidelity to actual flight conditions, precisely replicating how the system will operate in space. This level of detail is significant because it indicates that Landspace is not merely conducting tests for show but is genuinely pushing the boundaries of what is achievable with current technology. The rigorous simulation of the pre-launch and flight sequence validates the overall design and engineering of the rocket, which is crucial for its future success. Many observers may focus solely on the successful ignition and thrust output but overlook the importance of such fidelity in ensuring that the rocket can perform as intended during actual launches. 2. First stage reusability and cost reduction. The Zhuque-3 is engineered for at least 20 reuses with the potential to reduce launch costs by 80 to 90% compared to traditional rockets. This aspect is critical as it positions Landspace to compete effectively against established players like SpaceX, which has set the benchmark for reusability. The financial implications of such cost reductions could fundamentally alter the economics of satellite launches and other space missions, making space more accessible. Investors and stakeholders in the aerospace sector might underestimate the transformative impact that reusability can have on market dynamics and the competitive landscape. 3. Historical context and evolution. Landspace's journey from the failed launch of its first rocket Zhuque-1 to the successful static fire test of Zhuque-3 illustrates a remarkable evolution in capability. The pivot towards methane-liquid oxygen propulsion with Zhuque-2, which successfully reached orbit, demonstrates an adaptive strategy that many startups fail to execute. This historical context is essential to understand the resilience and innovation within the Chinese commercial space sector. Many observers may overlook this backstory, but it highlights the importance of learning from failures and iterating on technology. 4. Strategic goals linked to Tiangong Space Station. The Zhuque-3 rocket is part of a broader initiative to provide low-cost cargo delivery to China's Tiangong Space Station. This connection is vital as it underscores China's ambitions in space exploration and its commitment to developing a sustainable presence in low Earth orbit. Such strategic goals may not be emphasized in all reports, yet they are significant for understanding the long-term vision of China's space program and how it aligns with global efforts in human spaceflight and exploration. 5. Comparison with global competitors. While the reports note similarities between Zhuque-3 and SpaceX's Falcon 9, the implications of these comparisons extend beyond mere design. They indicate a competitive race in reusable launch technology that could drive further innovations and efficiencies across the industry. Understanding this competitive landscape is crucial as it can influence investment decisions, partnerships, and technological advancements in both China and the West. Observers might focus on the technical specifications and miss the broader implications of how this competition could shape the future of space access. 6. Automation in launch operations. The Zhuque-3 test utilized advanced automation, which not only enhances efficiency but also reduces the risk of human error during launch operations. This aspect of automation in the rocket's ground operations is significant as it reflects a trend toward more sophisticated and streamlined launch processes. As the space industry becomes increasingly competitive, companies that can leverage automation effectively will have distinct advantages. This detail may be overshadowed by the focus on the engines and overall test success. 7. Implications for environmental considerations. With the growing concerns about the environmental impact of increased rocket launches, the Zhuque-3's methane-liquid oxygen engines are noteworthy. Methane is generally considered a cleaner alternative to traditional rocket fuels, potentially mitigating some of the environmental impacts associated with space launches. This aspect of sustainability is often under-discussed in favor of more technical achievements. Yet it plays a crucial role in the ongoing dialogue about the future of space exploration and its environmental footprint. 8. Investment and financial backing. The mention of Landspace securing $123 million from China's National Manufacturing Transformation and Upgrading Fund highlights the growing support for private aerospace ventures in China. This financial backing is significant as it not only provides the necessary capital for R&D but also reflects government confidence in the commercial space sector's potential. Many reports may gloss over this point, but understanding the funding landscape is crucial for analyzing the viability and future directions of such companies. Conclusion. The successful static fire test of Landspace Zhuque-3 rocket is a landmark achievement that encapsulates multiple layers of significance within the context of space exploration and technology development. By focusing solely on the immediate outcomes of the test, many may overlook the broader implications that this development holds for the future of reusable rocketry, cost-effective space access, and the competitive dynamics in the global aerospace sector. These overlooked details are essential for grasping the full impact of this milestone and its potential to reshape the landscape of commercial space travel. 1. Milestone in reusable rocket development. The successful static fire test of the Zhuque-3 rocket is a crucial milestone not only for Landspace but also for China's ambitions in reusable rocket technology. Conducted on June 20, 2025, the test involved igniting 9 Tiangong, a methane-liquid oxygen engines in sequence, generating a total thrust of 7,542 knots. This achievement demonstrates the rocket's capability to replicate flight conditions and validates the compatibility of its major subsystems, which include engines, pressurization, and avionics. The implications of this milestone are significant, as it lays a solid groundwork for future orbital attempts and positions China as a competitive player in the global space industry. 2. Cost reduction and reusability. A key feature of the Zhuque-3 rocket is its design for reusability. The first stage is engineered to be reused at least 20 times, which has the potential to significantly reduce launch costs by 80 to 90% compared to traditional single-use rockets. This aspect of the Zhuque-3 aligns with the industry's shift towards sustainable space exploration and operations, where cost efficiency is critical for commercial viability. The ability to recover and reuse the first stage of the rocket not only enhances economic efficiency but also promotes a more sustainable approach to space missions. 3. Technical innovations and design similarities. The Zhuque-3 rocket's design incorporates advanced technologies including high-strength stainless steel for its storage tanks. The rocket's specifications, such as a liftoff weight of about 570 metric tons and a height of approximately 66 meters, are indicative of its robust engineering. Notably, there are design similarities with SpaceX's Falcon 9, highlighting a competitive landscape in reusable rocket technology. This comparison not only underscores the technological advancements made by Landspace but also reflects the global trend of innovation in the space sector, where companies learn from one another and push the boundaries of what is possible. 4. Strategic implications for China's space program. The Zhuque-3 is part of a broader initiative aimed at facilitating low-cost cargo delivery to China's Tiangong space station. This development is strategically important as it aligns with China's long-term goals for space exploration and presence in low Earth orbit. The successful execution of the static fire test propels Landspace closer to its inaugural flight, originally planned for the third quarter of 2025. Achieving this goal is crucial for China to maintain momentum in its space ambitions, especially in light of previous challenges faced by Landspace, including the failure of its first rocket Zhuque-1 in 2018. The trajectory of the Zhuque-3 development reflects China's commitment to expanding its capabilities in space exploration and its desire to compete on a global scale. 1. The Space Shuttle Program, NASA USA. The Space Shuttle program, initiated in the 1970s, was a revolutionary approach to reusable space transportation. The orbiter was designed to be reused up to 100 times with individual missions launching and returning to Earth, which allowed for significant cost savings and versatility in missions. The shuttle program successfully launched numerous satellites, conducted scientific research, and contributed to the construction and operation of the International Space Station (ISS). The inaugural flight STS-1 took place on April 12, 1981. And proved the viability of reusable spacecraft, leading to a total of 135 missions until its retirement in 2011. 2. Falcon 9 SpaceX USA. SpaceX's Falcon 9 rocket has set the standard for reusable launch vehicles in the modern era. First launched in 2010, Falcon 9 was designed with a reusable first stage capable of landing back on Earth after launch, significantly reducing costs associated with space travel. The first successful landing of the Falcon 9's first stage occurred in December 2015, marking a historic milestone in rocket reusability. Since then, SpaceX has successfully reused its Falcon 9 first stages numerous times, demonstrating the practicality of reusability in commercial spaceflight and enabling a new era of frequent and cost-effective access to space. 3. Blue Origin's New Shepard USA. Blue Origin's New Shepard is a suborbital rocket designed for space tourism and research. First launched in 2015. New Shepard features a fully reusable rocket and capsule system. The vehicle is designed to carry passengers and payloads to the edge of space and return safely to Earth, with a focus on the experience of weightlessness for passengers. New Shepard successfully completed its first crewed flight on July 20, 2021, carrying founder Jeff Bezos and others, showcasing the feasibility of reusable rockets for commercial space travel. The program emphasizes the potential for reusability to lower costs and increase access to suborbital flight experiences. The successful static fire test of Landspace Zhuque-3 rocket marks a pivotal moment in the evolution of reusable rocket technology and China's ambitions in the space industry. As we look to the future, several key predictions can be made regarding the trajectory of Landspace and the broader implications for the global space landscape. 1. Increased launch frequency and cost reduction. With the Zhuque-3's design allowing for significant reusability, aiming for at least 20 launches per first stage, Landspace is positioned to drastically reduce launch costs. Predictions suggest that as the company conducts its inaugural flight and subsequent launches, we may see a surge in launch frequency. By 2030, Landspace could potentially achieve a launch cadence comparable to that of SpaceX, with dozens of missions per year, particularly targeting low Earth orbit (LEO) markets. This will not only benefit commercial satellite operators but also facilitate more regular resupply missions to China's Tiangong space station. 2. Global competitive landscape. The Zhuque-3's design, which draws parallels to SpaceX's Falcon 9, indicates a growing competition in the reusable rocket market. As more companies, including those from Asia, Europe, and the US, invest in reusable technology, the market will likely become more saturated. By the end of the decade, we can expect to see a more diversified set of players, leading to increased innovation and potentially lower prices for launch services. This competitive dynamic may also push established companies like SpaceX to further enhance their own technologies and service offerings. 3. Sustainability and environmental impact. As reusable rocket technology matures, there will be a heightened focus on sustainability within the space industry. Landspace's use of methane as a propellant aligns with a broader trend towards environmentally friendly rocket fuels. By 2030, it is anticipated that regulatory frameworks will demand greater scrutiny of the environmental impacts of rocket launches. This could lead to the development of greener launch systems and increased investment in technologies that minimize the ecological footprint of space activities. 4. International collaboration and policy development. China's advancements in reusable rockets are likely to stimulate international collaboration, especially with nations looking to enhance their own space capabilities. By 2028, we may witness joint missions involving Chinese technology and international partnerships, potentially including collaborations with Europe and other spacefaring nations. This collaborative spirit could also lead to the establishment of new treaties and policies governing space traffic management and the sharing of space resources. 5. Technological innovations and next-generation rockets. The successful test of the Zhuque-3 will likely lead to accelerated research and development in next-generation rocket technologies. Innovations in engine efficiency, materials science, and autonomous recovery systems are expected to emerge, driven by both competition and necessity. By 2035, we may see rockets that are not only more efficient but also capable of carrying larger payloads to higher orbits, significantly expanding the operational capabilities of commercial spaceflight. 6. Expansion of commercial space ventures. As Landspace continues to make strides with its Zhuque-3 rocket, the broader commercial space sector in China is expected to flourish. By 2030, we can anticipate a proliferation of startups and established companies exploring various aspects of space, from satellite internet services to lunar exploration. The Chinese government's supportive policies toward private space ventures will further catalyze this growth, positioning China as a leading player in the commercial space sector. 7. Enhanced national security and space sovereignty. The development of reusable rockets like the Zhuque-3 will strengthen China's capabilities in space, providing the country with greater autonomy in launching its satellites and conducting space missions. This is likely to have implications for national security as countries increasingly recognize the strategic importance of space. By 2030, the defense sectors of various nations may emphasize the need for robust space capabilities, leading to an arms race in space technology. Conclusion. The successful static fire test of the Zhuque-3 rocket represents not just a milestone for Landspace but a catalyst for a new era in space exploration and commercial endeavors. As we move towards 2030 and beyond, the implications of this technological advancement will reverberate throughout the global space industry, impacting everything from launch costs and environmental sustainability to international collaboration and national security. The future of space exploration is poised to be dynamic, competitive, and increasingly collaborative, with the potential for unprecedented advancements and discoveries.